Welcome to Chapter 2 for Math 20-1. This is the 2.1 instructional video where we're just going to lay down some of the terminology that I'm going to use throughout the chapter. We're going to talk about drawing angles in standard position, and we're just going to look at one rotation, so from 0 to 360 degrees. But really important, the way that we draw these angles in math is that we always start in the positive x-axis. So we call that the initial arm, where it would sit if we weren't rotating. And then the way that we draw that angle is that we rotate, and some students are frustrated by this, but we rotate counterclockwise, whatever the angle requires. Now, immediately what that means is that if I did want to label my different axes, then the positive y-axis is 90 degrees, negative x-axis is 180 degrees, negative y-axis is 270 degrees, and then back on the positive x-axis would be 0 or 360. We aren't going to go past 360 this year. You'll deal with that in Math 30-1. This is very, very much the terminology and the trig that we're going to use in 30-1 math. So it's important that if nothing else, you remember the terminology and how we draw angles and a few other techniques. Now, when we do draw this, the Cartesian plane can be split up into quadrants. Quadrant 1 is from 0 to 90, quadrant 2 is from 90 to 180, quadrant 3 is from 180 to 270, and then again, quadrant 4 will be 270 to 360. So that angle in standard position is where we start at the initial arm, rotate counterclockwise, and then the terminal arm rests when we've rotated through theta degrees. Now, when we deal with this and when we draw angles, there's a few things that come up. And so it's going to be a relatively long instructional video. Reference angles are defined as the smallest angle between the terminal arm and the x-axis. So you can see that definition right here. Good idea to fill out those definition pages on the notes because writing it down helps you to remember. There are formulas for this. You can manipulate these using kind of, maybe not simple, but decent geometry. If you're in quadrant 1, then the reference angle is the rotational angle. If you're in quadrant 2, the reference angle is 180 minus the rotational. Quadrant 3, your reference angle is theta minus 180. And then in quadrant 4, it's 360 minus theta. I'm going to work through that on a couple of the examples in the notes, and we'll talk about how you can do that logically as well. But some students, and several of my Math 30 students do this, they will memorize these 4 angles, or these 4 formulas, I should say. It's actually a little bit more useful, I would argue, to measure or remember the formulas for the rotational angle, theta. That's the angle in standard position. But we're going to focus a little more on getting the reference angle this year. So they do give a bit of an example. And this is from your textbook if you'd like to see it in paper in front of you as well. So when you draw 20 degrees, the reference angle is 20 degrees. When you draw 160, the reference angle is still 20 degrees. And that's really important that if we give you a reference angle, you will be tested on being able to find the 4 rotational angles that all share that reference angle. So 20, 160, 200, and 340 all have a reference angle of 20 degrees because all of those terminal arms would be 20 degrees from the x-axis. All right, as if that weren't enough to give you information in Chapter 2, we're also going to deal with something called the special triangles. And the reason why we like these triangles is because they're perfect, they're exact, and they contain sides with length 1. Now, we're going to work through this in the notes, but there's 2 types of triangles you have to know. There's the 45-degree triangle, which is isosceles. That's why these 2 sides are 1. And if these 2 sides are 1, then according to Pythagoras, which is the work right here, C must be root 2. So we're going to look at actually drawing these triangles out, and it certainly becomes a part of Chapter 2 for you to know these triangles. You have to have them memorized, and that's a really important consideration. We're going to use them a lot in Math 30 as well. The other triangle you have to know, and they present it this way as 60, 30, 90. It's fine to do it that way, where we make just kind of the easiest side, the adjacent side 1 for the angle 60, and then the hypotenuse is 2, and when that happens, we get a perfect root 3. Now, the reason why this is so useful is we can come up with the trig ratios for these angles. So if you look at my 45-degree triangle right here, the opposite side is 1, the adjacent side is 1. So the tan of 45 degrees is 1 over 1. But if I do cos or sine, look how I get the same value. Cos is adjacent over hypotenuse, and sine is opposite over hypotenuse. And we'll push a little more of that trig that you've learned in the past. The technique that you probably have for remembering these is SOHCAHTOA, where sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. The one thing that we are going to focus on a little more in the notes is the idea that we really should rationalize denominators when they have radicals there. So you will see, this 1 over root 2, and I'll do it as well. I will write it as root 2 over 2, using that chapter 6 technique, which is rationalizing the denominator. All right, so I would just like to go through a couple of these examples now with you guys. The one thing that I do want to do right off the bat is to label these special triangles. Now, it takes a little bit of practice, but I hope we can all agree that this is the 45-degree triangle because these two sides are equal. So I would put a 1 on both of those sides. If both of those sides are 1, then the hypotenuse needs to be root 2. And, moreover, if we wanted to, we could put a 45-degree angle up there as well. This is the 60, 30 degree, 90 triangle. So a 60 degree would go on the bottom. A 30 degree would go up top. Just going to try to sneak it in there. The adjacent side is 1. The hypotenuse is 2. Well, that 2's locked in place. Whoops. So the hypotenuse is 2, and that makes the opposite here root 3. Now, this is still Pythagoras. The reason we generate them this way is because this allows me to say the cos of 60 degrees is adjacent 1 over hypotenuse 2. And I know that the cos of 60 degrees is 1/2. Now, your calculator can do that as well, but these special right triangles are a tool we need to really get into that trig concept in math classes.